Hello Opcode, hello Dubai. First of all, order of business, I'd like to extend the warmest thanks to everybody that stuck around up until now. I know that no matter how entertaining or educational a conference is, it's very difficult to stay up until the last talks. So you guys are the real MVP. Okay, so today we're going to talk about sort of a still non-traditional way of hacking stuff. I'm sure you're familiar with the way IoTs are hacked today. Brute force telnet, command injection in a web interface, stuff like that, right? Right? Yes. Thank you. So let's start with IoT. Now, the reason this slide is in my deck is because every now and then, whenever I go places, people tell me that they don't embrace IoT. So how many of you are adopters of IoT? Okay, so let's take a random example. You, sir, you're not an adopter of IoT, right? Oh, you are. So who isn't? Who doesn't own smart devices? Matt. Cool. Now, the thing with IoT is that it's not optional. You cannot not use IoT. It gradually creeps up in your life without people acknowledging it. I mean, we used to have dumb TV sets. Now all the TV sets are smart. And pretty soon, you're not going to have the option to not purchase a smart TV, right? We used to have parallel port printers for people who remember like 20 years ago, then USB-connected printers, and now all the printers are network connected. And they have a small operating system and a small telnet interface and a small web interface with no authentication and all that good stuff. And this is going to gradually continue on this path. It makes our lives easier, automating stuff, monitoring stuff. It also makes the producer's life easier because they monitor our behavior and it enables them to sell better to us, right? Like your Fitbits and all that stuff. So let's look at the IoT stack. What if I told you that an IoT is very similar to a WordPress website? Can anybody here tell me why? Come on, try. So IoT is like a WordPress website. Well, the quality of code is bad everywhere, but good point. 5 points for trying. So let's look at this. We have, is anybody here old enough to remember this? Matt Boz? Yes. So, yeah? Hardware, we have a Linux operating system, Red Hat 6.2, and VU FTPD server, also known as providing root access since 1996. Another stack, hardware operating system Windows and IIS 5.0. Another stack, we have hardware Windows RDP. Now, think of similarities between these, okay? Another stack, we have hardware, whatever operating system, Joomla. Now we have hardware, operating system, and an application layer, right? And very often, in the case of IoT, it's that application layer that gets exploited. Now, in the case of IoT, we have hardware, BusyBox, application layer, cloud, and mobile app, which essentially means that because that application layer on IoT is always, but always a web service, susceptible to the exploits of web services, like command injection, all that stuff. But the main difference between websites is that IoTs have a larger attack surface because they also have a mobile app, which is part of the attack surface, and they also have cloud, which is also part of the attack surface. So for those of you who want to get into IoT hacking, we're just going to go very briefly through the things to look for. So, software. Telnet is still a thing in 2019. If you go on Shodan, it's like 6 million Telnet services running. Look at the mobile app and device communication because very often you can emulate the behavior of the mobile app, and very often the mobile app calls functions in that web service that call system commands, so you can achieve command injection. You look for directory traversal, buffer overflows. An important thing to mention, I'm sure you're familiar with ASLR. So ASLR was implemented in order to prevent predictable code execution when achieving a buffer overflow, right? Because the executable would be loaded at different memory addresses, the functions would be at different memory addresses after each reboot. So you wouldn't know where to inject your code after achieving a buffer overflow. In the case of IoT, ASLR is non-existent. So even though ASLR is enabled in the operating system, the binaries in IoTs, literally all the IoTs that we have investigated so far, they're not compiled with support for ASLR. So there's a flag, PI, stands for Position Independent Executable. No binary on IoT is compiled with the PI flag enabled. So that means that if you achieve a buffer overflow, you're going to have a predictable memory address for code injection. Worth mentioning, a lot of different vendors share the same code. We did a talk at DEF CON a few years ago, how to hack about 200,000 devices, different vendors, but the same firmware. So once we found vulnerabilities in that firmware, then you can literally hack all those brands that were based on that firmware. Backdoors, credential reuse, private key use, cloud chatter. We're not going to spend too much time on this because we want to focus on the main topic of the day. But if you have questions on this, save them for the end of the talk. So I think it's important to also mention, if you have no way to hack the device in the initial steps, a very efficient way to get access to the file system is by doing bootloader hijack. I'm sure that many of you are familiar with the way to get access back to a Linux system, right? By hijacking group. You just hijack group, pass the parameters to the bootloader, say init equals bin bash. So instead of the original init script, you get bin sh or something like that. It's the same thing with IoTs. They have a bootloader. It's down here. And you can just pass all these parameters to the bootloader as long as you can interrupt it. And very often, you just hook up to the serial interface, and you can interrupt it. And then you get a shell in the smart device. And you can just grab all the files so you can analyze them offline on your computer. I think also wanted to talk a little bit about the Heuristic botnet. So this is a botnet that we've been tracking with our honeypots. And the reason it was interesting it didn't do anything. It just grew. It got to its peak. It was about 80,000 victims. But what was interesting was that it kept adding functionalities into it. It had file harvesting functionality. It had data exfiltration functionality. They added DDoS functionality at a later point. It was peer-to-peer, which meant that you could not kill the CNC and disable the entire botnet. Everything was propagated through the network. It was actually using DHT, so the BitTorrent protocol, to propagate commands, to update, to add new functionalities, to add new files, and so on and so forth. And very interesting, in October, it added support for ADB. So ADB, Android Debug Bridge, also has a network option where you can connect to an Android machine via the network. And we said, nobody's stupid enough to have a network-enabled ADB available in the internet. But when we saw this added into the Heuristic botnet, we said, okay, let's check it out anyway. We went to Shodan, we port 5,000, and wouldn't you know, there were like 7,000 Android devices with ADB interfaces enabled. Smart TVs, kiosks, maybe payment systems, So yeah, actually, POSs from bars. So, because yeah, why not? And again, no other activity other than spreading and adding functionality. And our supposition is that it's used exclusively for testing new functionalities for botnets. Now, on to the main topic. Godzilla Smart Home Security Camera. These are the culprits. Yeah, it's smart guard for your wall. Well, it's a security camera. And the little guys here, if you can see them. So the first thing that we did, we studied the mobile app behavior. We saw that it was talking to an API on the Godzilla website, on the Godzilla cloud. And I think this is one of those moments when I tell you about this new vector of attack against smart devices because it's really, really cold. Godzilla is not the only ones that we've managed to break into through this. So traditionally, it's like point and shoot. You have an IP address with some open ports, and then you find some vulnerabilities, and you exploit them, and you break in. But what if you don't have direct access to that machine? What if you don't have any kind of open ports to get into? What if that particular target is behind NAT? No port forwarding, nothing like that. You use the cloud. You relay all your stuff, all your dirt, all your buffer overflows, all of your command injection through the device's cloud. Because the cloud is an input to the device as well, right? There's functions in the code of the device that parse information that comes from the cloud. So if you can trick the cloud into relaying dirt to those functions, and those functions are vulnerable, you're going to achieve command execution. So it's pretty cool. We also did it with a power outlet from Edimax, same stuff. Full connect back shell from behind NAT, so hacking it from Nepal, power outlet in Romania. So after you register the account, you're assigned user ID. Ours is 400,008, 311. And comes the fun part. It cannot be changed. And it's incremented by 1 for each account. And actually, I could stop the presentation right here, because everything is dependent on this user account. So the form of authentication that's being used, the only actually valid form of authentication that Godzilla uses in their cloud to validate interaction with the devices is this user ID. And the reason it's called, the talk is called hacking 450,000 devices is because the number is actually much bigger than that. Right now, this user ID is at about 498,000. And each user ID can have multiple cameras associated with it. Also, the posts are encrypted with AES-256 CBC. However, the encryption key and the initialization vector are hard-coded in the app. So yeah. And did I mention that the UID is sequential? So we wrote a script that essentially tries to pull information from the Godzilla cloud to see what can be seen about a device. So with that in mind, let's see. We're just going to use our own user ID. And I actually got a wine-liner here someplace. No, not this one. I'm just going to skip a few things and beautify it, because it's a JSON that comes back. So all I, wait, let's do this on my machine. So what do we have here? The only parameter that we used is this 408.311. The Godzilla user ID, this password, these two are hard-coded, are the same everywhere. So we don't even worry about this. We just reuse them. We extracted them from the mobile app, and we're just reusing them for all the user IDs. Okay? So the only thing that changes is this number, 408.311. And we get back that I have two cameras. Okay? One called Bug Boy with this UID, and this is going to be reused later. And the other one called Tiny Bug with this user ID. So it's that simple. And again, just change the number 311 to something else, and you're going to get the details from somebody else's house, bedroom, bathroom, and so on and so forth. And obviously, a scary thing is that these people, while we were doing the analysis, we at some point realized that these are so goddamn broken that anybody could have snooped on us while we were doing the research. We actually came to this realization like a few days in, and that one like, oh goddamn, okay, so tapes everywhere on the microphone and on the camera, on everything, because you can just see and manipulate these things in any way you want, right? So again, this is a beautiful version with JQ of that JSON. And from this, we're going to remember the device ID, so 5pk blah, 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 and this password admin. You cannot change this. So for a full account takeover, we just explored the API. You can call upon the API to change the user's password, change the user's email, and get a full account takeover. Arguably, that's going to give you away, and the user is going to know that you did something, to steal their cameras, and you don't want that. So this is not that interesting. However, this is more interesting. There's a function in Guardzilla called invite a friend, in which you, in theory, from the mobile app, you invite somebody to see your camera. However, if you do it just by calling upon the API, the owner doesn't get any kind of notification that they've sent an invite. However, the attacker gets this email. So we're going to try to do it now. How am I on time? Lots of time. Cool. So let's open the Guardzilla app first. And mirror my phone. Cool. So I've sent an invite. And let's see what we'll see. Oh, look, I can accept this invite. I just installed the mobile app, and of course, a different account than the owners and so on and so forth. So now this is going to be in my cameras. Oh. And there you guys are. So, and this is the easy way, but just for the sake of it, we also implemented a hard way to view the stream without invites or whatsoever or whatever. So we just, I'm not going to put the slides. Just for the hell of it, we implemented an emulator of the app that could just tap into the video stream and pipe it to VLC. Funny story with that as well. It's very often easy in those particular cases when you report stuff, right? So this gives the stream to a local pipe, and
did you ever try that kind of like to cross-invite people that live close to each other or something like this?
we don't know. So again, this is just direct brute force into the stream. Right? Thank you. Okay. However, you were promised next generation botnets, not just peeping into people's bedrooms, right? So the first thing, buffer overflow in the cloud agent. They use a platform called Calais platform. Now, in our research, we've discovered that a lot of devices, and we actually have something upcoming for this August, they use this Calais platform, almost all of them, and for all intents and purposes, that platform is okay. It's just the implementation in each vendor that's broken. They have a combination of peer-to-peer relays, and the whole purpose of the platform is that they provide, if you implement their agent in your camera, they provide NAT traversal so you can access the video feeds. But we did some code analysis. We just put the binaries in IDA, and tried to generate some code, and we found that a specially crafted buffer can be sent through the cloud, relayed by the cloud into the device, and you get predictable RCE. So remember this function, TK set device model request handle, and remember this function, actually, the case 0x458, because this is our reference into relaying the command through the cloud. We see here two string copy, and we essentially overflow the first one, get into the next one, up until we reach system at 81380. And long story short, this is the almighty exploit. You send to the cloud a buffer with the commands, with the proper size, and don't get command execution. And you have to call the that 0x40058, which is the reference in the binary, in the local binary on the camera. Yes. So the main binary will crash, but only after the command is executed. So let's try it. And just to show that I'm not doing it locally, I'm going to do it from a remote server. Right? So someplace in the US, right? Okay. So
Do you know which device you attacked?
yeah, the big one. I got the parameters for the exploit for the one that we built. It's simple. It's just the device ID and the password. The password is always admin, and the device ID you can get with the initial query into the Godzilla API. And we have a listener set up here. And assuming that the internet connection works. Let's try it again. Actually, let me see something else. See, it works better if they're powered on. So to save some time, up until it takes like a couple of minutes to boot, first round of questions. So somebody asked if we notified the Godzilla people. We notified them in August 2018. They didn't reply then, and then some guy published a vulnerability that we already knew about on some zero-day forum. It was not a very fancy vulnerability. It was, he found the key to the keys to an AWS bucket, and he actually didn't find something much cooler about that AWS bucket, which was that besides being read-write, it also had a directory index. So you could see all the recordings from all the people. And that kind of forced our hand to publish our paper. It was like November or December last year. And when that happened, I got a call from the director of product management from Godzilla. And he said, dude, why did you publish? Why didn't you contact us? Well, we tried. And here, us asking you for the PGP keys, and you're not replying. We're trying again on all those email addresses. And so, okay, we're going to do better. But I asked, did you do any kind of pen testing, any kind of security audit before you published the product? And he said, yes. Did you pay a lot of money for that? So yeah, I think that we're online. So we're going to try this again. What do we have here? So I ask you, gentlemen, is this not an easy way to create a botnet? So we have shell, root shell on the big guy. And just for the sake of it, we're going to get root shell on the little guy with a different vulnerability. Command injection. So the Godzilla supports remote upgrade, which essentially says you can send a string to the API telling Godzilla update by using this package from this URL. And the only condition is that to trigger that process is that the URL has to be valid, but it doesn't have to have anything valid in it. It just needs to be able to reach it.
They don't have authentication.
Oh yeah, sure they do. It's that user ID. So the firmware is concatenated in a Theyre archive, and essentially the code looks like this. Now, 5 points to the person that can spot the command injection. Hint, it's blurred by a line in the TVs. Where? Yep. So it's the Theyre command executed with the system. Because if it executes Theyre, executing Theyre on a Linux system, you can just change the name in semicolon something. It ends Theyre and continues with whatever you put after semicolon. So let's get another shell on a different machine. Set up the listener. And shell, yet again. So this is a shell on the little guy. And actually, if you guys want, while I'm still on it, if you guys want to run any kind of commands, just tell me. I will be happy to type them in for you. Ten megabytes of storage space. Usually they store the recordings on external storage. And this is the mount table. This is my shell. Okay. So bonus, AWS bucket. The camera records videos in order to facilitate, if you have a security camera and you want to review past recordings, what happened yesterday, 5 days ago, right, blah, blah. The camera sends those recordings to a cloud, and actually it asks for money, much like the Nest business model or the Arlo business model. If you want to be able to access your recordings from 30 days ago from a place that anybody can access, but people don't know that, then you have to pay a subscription. It's actually part of the setup flow. As soon as you're done with the setup, they ask you for money to access this AWS bucket. Little do their users know that, fun fact, it was read-write, we got the keys, and it also had directory index. And also, I think it's worth mentioning that out of all the things that I have described now, this is the only thing that they fixed. The thing is, the whole thing starts with that predictable UID. Because all the interactions that you have with your cloud have to do with either a device ID, when you interact directly with a device, or if you don't know that device ID, you just query the user ID, and that user ID gets you the device ID. And since they've already assigned predictable UIDs to all of their users, they kind of have an architectural problem to change that. So as of now, it's like almost 500,000 user IDs, which I don't know how many cameras associated with each one. You can query all of them and get all that information, get RCEs, get access to the video feeds, and so on and so forth. So to sum up, basically all the things that I've just said. Now, as takeaways, I think it's worth mentioning that IoT is and will continue to be a huge attack surface, simply because from our research, we've been doing this for the past 4 or 5 years, right? We had a lot of focus on IoT, and We're not looking at perimeter-based attacks, so we're not looking at things that you can hack in your house, because those things are also fundamentally broken. You can just stream stuff on a Panasonic TV without authentication, for example, but that's considered by design. But we focus a lot on mass hacking, on things that can be hacked like in hundreds of thousands, and so on and so forth. And other than companies like Google or Amazon or Apple, or companies that we know are kind of security conscious and answers to bug bounties and have bug bounty programs and do proper pen testing on their stuff, all the others had buffer overflows, command injection, blah, 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 blah. And I think we only had one reply to our notification emails ever from a German company. So props to the Germans. You can leverage the cloud to inject commands. And I think this is one, if you want my suggestion, this should be one of the key takeaways from this talk. So rather than targeting and dropping the research on a device because you cannot directly access it, try to study how the device interacts with the cloud, what kind of inputs it receives from the cloud, and see if you can trick it into receiving something evil or malicious. So vendors need to pen test their products thoroughly. And unfortunately, obviously, this is not happening. Run bug bounty programs, this goes without saying, and have proper and unattended update mechanisms. So some people ask me, Jay, how do you know if a device is secure? You know, if like just the first thing that comes to mind, how do I know if a device is secure? Because I don't have a lab, you know, I don't have like your team to do vulnerability research. I don't know what Wireshark is. I don't know what TCP dump is. I don't know what whatever, you know, curl is and all that stuff. How do I know if a device is secure? And the golden rule in my small world is look at the update mechanism. Inherently, as we all know, everything is flawed. These vulnerabilities are discovered in all systems on a weekly basis, if not on a daily basis or hourly basis. It's all a matter of how that vulnerability is patched, fixed, and that fix delivered to the end users. We identified a command injection in the EddieMac Smart Power Outlet. They published an update. 1 year later, I was in a big office, and the CTO of that company, huge as somebody would say, had that power outlet in his house, and he told me, come on, root my house. Dude, are you sure? Yeah, man, I'm not afraid of it. Dude, are you sure? Yeah, okay, root. This is your Wi-Fi password. These are the other devices in your house. And we were in his offices in Minneapolis. And as it turns out, he had that power outlet. EddieMac issued the update a year before that, but he didn't apply it. Nobody applied it. Because when we saw the update for the EddieMac power outlet in the mobile app, you tap OK, and then it takes you to a non-mobile friendly website where you have to download a binary firmware file that you have to upload to the power outlet through such a complicated process that even us couldn't apply it to test the patch. So the update mechanism, unattended updates, is the key thing to look for in a device if you want to know if it's secure or not, because people will patch stuff. They're not that bad. You know, they reach out, they outsource, they whatever. But being able to receive that patch is the most important thing. And of course, it's still trivial to get full RCs on IoTs. And with this, this is how I finish all my talks on IoT. I encourage the security community to go and try to find vulnerabilities and RCs that could compromise things en masse, because otherwise the botnet people are going to get ahead of us, and we're going to see Mirai version 2. I mean, the whole thing with Telnet and command injection and GPON and all that stuff with Huawei and blah, 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 that's going to finish probably in a couple of years. Telnet hopefully is going to finish before that. And that's when the botnet creators are going to focus on the new things like this. And this talk is going to go live probably at some point soon. So they're going to be inspired by this and so on and so forth. So we need to expose as many of these types of vulnerabilities as possible. And with that, I thank you for sticking up for so long, and I hope you enjoy this.